And today we have a special guest, Mr. Cryan.
Hey.
Alright, well today we're going to be talking about the coefficient of friction. Well, what is friction? There are two types of friction. There is static friction and kinetic friction. Static friction is the force between two objects when neither of them are moving. Kinetic friction, on the other hand, is the force between two objects when one object is moving or if two objects are moving against each other.
So today our main focus is going to be the coefficient of friction. So over here, Mr. Bryan, as you can see, is our definition of the coefficient of friction. It is the value that shows the relationship between the force of friction multiplied by the normal force.
Did you know about this before, Mr. Cryan?
I know how to multiply, but I'm not too good with this physics stuff. So.
Well, I'll explain to you this equation.
Oh.
Okay. Do you know what this part means?
Something to do with friction?
Along those lines, yes. This is the force of friction equals the multiplication of mu k, which is the coefficient of friction, multiplied by the normal force.
Alright, so today we're going to be demonstrating this, Mr. Bryan, through a ramp problem.
Oh.
Have you heard of a ramp problem?
I've seen ramps before.
Yeah.
This kind of looks like a right triangle.
Something along those lines. It's a ramp, but yes, a right triangle.
Okay.
So, are you familiar how I would solve this theta? Possibly, but how can I solve it? How can I
like
solve
look for an angle?
Yes, I want to look for an
Well,
angle.
if I had a right triangle, I'd probably use some trigonometry.
You're right.
Oh,
So good to have you here, Mr. Cryan.
I'm happy to be here.
That's great. So, since you said we use trigonometry, what I know is we can use SOHCAHTOA, sine, cosine, or tangent. In this case, what seems best is we can use tangent. Tangent, defined with theta, is opposite over adjacent. Well, since we have this delta y and this delta x, we're trying to solve this theta right here. So, what is the opposite of this angle, Mr. Cryan?
The opposite of this angle would be this side here.
Which is the delta y.
Okay.
And the adjacent of the displacement, what would that be, Mr. Cryan?
I think it'd be the distance from here to here.
Yeah. Yep.
Yeah.
And that's how we solve our theta. Well, now we're going to demonstrate, with some pumpkin pie with some delicious whipped cream placed on top. And this is how we are going to find the coefficient of friction with a pumpkin pie to celebrate for our Thanksgiving coming up next week.
Pumpkin pie is awesome.
Pumpkin pie is awesome, and
Yes.
Thanksgiving is next week. So happy almost Thanksgiving. And this is going to be rolling down the ramp.
Okay, this seems like it could be bad. Did you want me to catch it at the end?
Yes,
Okay.
yes. We don't want
We
to
wouldn't
fall.
want to get the floor dirty.
We wouldn't.
No, we wouldn't want to do that, so I'll catch it here.
Alright, Mr. Cryan,
All
are
right,
you ready?
I'm going to catch it.
Alright.
This could in no way go bad. Let's catch it.
Ready?
Let's hope it doesn't fall.
I'm watching friction happen right before me, and I got it. That was
Really?
perfect. Oh. That 3.14 is delicious.
Are you okay?
I'm great. Oh,
That's
oh yeah.
I'm so glad we could have
Oh.
you here today.
Well, at least you're in the Thanksgiving spirit, but
I didn't see that coming at all.
that white mustache
All
makes
right.
you seem a little bit more interested in our Christmas spirit.
I'm sorry if I interrupted you.
Thank you. I know so much more about friction now. Thank you.
Thank you so much for helping us host this. Goodbye, Mr. Cryan.
All right, see you later.
All right, goodbye.
Alright, well, as shown in our previous video, we are solving for a ramp problem, except that Mr. Cryan had to leave, so normal special guest for him. So, we set up a free body diagram and labeled all of our forces of our applied force, our normal force, our force of friction, and our force of gravity. First, we had to solve for our theta, which is in the previous video. We explained that we were going to use inverse tangent times delta y over delta x. So we plugged in our numbers and got theta to equal 14.5. So then we solved for our force of gravity, which was the mass of the pi times gravity, which is 9.8, and we ended up with 6.664 as our result. And we know that the force of kinetic friction is equals the force of friction from the sum of force of friction. So we have this equation, and we are also going to use this equation. F of k equals mu k times Fn, which is the force of kinetic friction times the coefficient of friction, well, the force of kinetic friction, coefficient of kinetic friction times the force, times the normal force. So our first force that we're solving for is the force of friction, which we know is mg sine theta. So then we plug in all of our numbers, and our force of friction is 1.67 meters. Our next force that we know is Fa. Well, we don't know, we're talking. So we know Fa equals Ma from previous lessons. And we also know Fa equals mg sine theta because of the free body diagram. So then we substitute in Ma for Fa, cancel out the m's, and we get the acceleration of the horizontal displacement to equal g sine theta. We get 9.8 sine 14.5 and get the acceleration of the horizontal displacement to be 2.45.
And the next force that we will be solving is the normal force, in which is used in this equation, which is the force of kinetic friction equals mu k, the coefficient of kinetic friction, times the normal force. So we need to find normal force, and to find normal force, we use mg cosine theta, m, the mass of the pi, g, gravity, cosine theta to be found is 14.5 using SOHCAHTOA as tangent used, which is 14.5. Multiply all these numbers to give you a total normal force of 6.45 newtons. Now to find the applied force, we use net force equals force applied minus force of friction. So we typically know F equals MA, but we don't know our total force. So our total force is applied friction minus force of friction. Applied friction minus force of friction. And MA, which is F equals MA, put that there. Mass, 0.68. Acceleration, which we just found previously to be 2.45, plug that into here, equals force applied, in which we have no idea what it is, that's what we're trying to solve, and force of friction, in which we solve over here to be 1.67. Multiply these two numbers, the mass and acceleration to be 1.66 equals force applied, which is the unknown, minus the force of friction to be 1.67 up here. Do the inverse operation of negative 1.67 to be 1.67. Turn it over here to this side, 1.66. These two multiply plus 1.67 to isolate force applied. Force applied with these two numbers added is 3.336 newtons. Now that we have force applied, we use force applied minus force of friction, which was used here, to find the total forces equals F net, Force applied, 3.336, which is found down here, minus force of friction, which we found previously over here to be 1.67. Subtract these two numbers, you get your total forces, your F net forces, which is 1.66 newtons. And going back to Fk, which is force of kinetic friction, equals mu k, coefficient of kinetic friction, times normal force. Again, we are trying to find mu k, coefficient of kinetic friction. Since we have Fk, which is our force of friction, of kinetic friction, to be 1.67 newtons, we plug that into here, equals mu k, coefficient of kinetic friction, in which we're trying to find, force of kinetic friction, in which we're trying to find, normal force, which is 6.45, in which we have over here, which we solved, plug that in, isolate the 6.45, cancel that out, divide by 6.45, the force is normal force, divide these two, and you get your mu k, your force of kinetic, your coefficient of force of kinetic friction, to be 0.258. It is a unitless coefficient of kinetic friction, and typically mu of either static or kinetic is meant to be less than 1. And now we've solved the coefficient of kinetic friction using only our mass, in which we found of the pi, the displacement, the height, and the equations in which we're given to find either Fa, Fg, force of friction, and normal force. All these equations were used to solve for the coefficient of friction. And thank you again for your time. I hope you learned something in how to find the coefficient of kinetic friction. Jenny, do you have anything else to say?
No.
Thank you again to Mr. Cryan
For helping us with our real life ramp problem.
and